Our goals are to expand the scientific understanding of the Earth and the universe, create innovative new space technologies, and to extend and sustain human activities across the solar system.
An organization that dates back to 1915, called NACA, is the force behind the United States air supremacy during World War II. Years later, in 1957, the Soviet Union launches the first artificial satellite, the Sputnik 1. NACA is then absorbed into the newly formed NASA on the 1st of October 1958, with a budget of $89 million. The space race begins.
The Jet Propulsion Lab uses a Juno 1 rocket to launch the first United States satellite, the Explorer 1. 11 months later, JPL is absorbed by NASA. The Apollo program is announced. Test pilot Neil Armstrong takes his first test flight in the experimental X-15 rocket-powered aircraft. In the X-15, Neil Armstrong reaches an altitude of 39 miles, or 62 kilometers, and speeds of 3,989 miles per hour, or 6,419 kilometers per hour. A Project Mercury spacecraft takes astronaut Alan Shepard on a 15-minute suborbital flight, making him the first American in space. 1 month after the Soviet Union puts the first human in space and the first to orbit around Earth. The 5-year Project Gemini comes to an end. Missions include an endurance flight of nearly 14 days in space, overshooting the 8 days required to do a round trip to the Moon. The project also achieves sending the first onboard computer into space, the first docking of a crewed and uncrewed spacecraft, and Buzz Aldrin completes the first work-based spacewalk.
But why, some say, the Moon? Why choose this as our goal?
The first crewed mission of the Apollo program ends in disaster, with 3 astronauts losing their lives. NASA launches the first working orbiting space telescope, the OAO-2. Apollo 8 takes astronauts away from Earth's orbit for the first time and sends them on a flight around the Moon.
3, 2, 1.
Apollo 11 launches, sending a 3-person crew on their way to the Moon. 4 days later, the lunar module Eagle makes touchdown on the Moon at the Sea of Tranquility. Neil Armstrong and Buzz Aldrin step onto the Moon, while fellow astronaut Michael Collins orbits above in the Columbia spacecraft. Armstrong and Aldrin spend 21 hours and 36 minutes on the lunar surface. 4 days later, the 3 astronauts splash down in the Pacific Ocean, southwest of Hawaii. They bring back the first geological samples from another planetary body. The 22 kilograms of material includes 50 lunar rocks and lunar soil dug up from below the Moon's surface. 4 months after the first humans set foot on the Moon, NASA launches Apollo 12 with another set of astronauts that lands on the lunar surface. Apollo 13 malfunctions 2 days into their journey when an oxygen tank ruptures. They loop around and orbit the Moon before heading straight back to Earth. Apollo missions 11, 12, 14, 15, 16 and 17 all land humans on the lunar surface, resulting in 12 people setting foot on the Moon.
Memory foam begins to make its way into everyday objects, from beds to American football helmets. NASA funded the research to make the temper foam in 1966 as a way for NASA engineers to create custom seats for aircrafts. NASA's Mariner 9 spacecraft arrives on Mars after a 5.5-month journey from Earth. It is the first spacecraft to orbit another planet. Spending a year orbiting Mars, mapping and taking measurements, it sends 7,329 images back to Earth. NASA launches Skylab, the United States independently built space station. Skylab is equipped with a zero-gravity shower system, sleep compartments, toilets, solar panels, and a telescope, and is occupied by 3 crews for a total of 171 days. The Voyager 1 probe launches on a mission to study the outer solar system. As Voyager 1 continues traveling through space long after it has lost power, a gold-plated record has been placed on board for potential alien civilizations to discover. It contains scientific information, spoken greetings from world leaders, and photos and sounds of Earth. NASA's Viking 1 and 2 land safely on Mars after an 11-month journey from Earth. On Mars, the Viking landers stay in place and begin recording the surroundings. For the next 6 years, they study Mars's atmosphere and surface and search for evidence of life. 2 years after launching, Voyager 1 arrives at Jupiter. Columbia, the first spacecraft of the Space Shuttle program, launches. It becomes the first reusable crewed spacecraft and can carry a crew of 8. It is also the first spacecraft capable of carrying large satellites to and from orbit. Shock absorbers developed back in the 1960s to protect spacecrafts and launch pads during launches are now being used in buildings and bridges to absorb shocks during earthquakes. Voyager 1 takes its final image, creating the solar system family portrait, with Earth as a distant pale blue dot. The Discovery Space Shuttle carries the Hubble Space Telescope into orbit. The telescope provides the deepest views into space and allows humans to establish the presence of black holes. NASA needs to miniaturize camera sensors for their missions while keeping scientific-grade image quality. Eric Fossum from NASA's JPL leads a team that invents the CMOS active pixel camera sensor. The new sensor, used to create the smaller and lower-powered NASA cameras, later spreads across the world, not only being used in dental cameras and for motion capture, but they also allow for cameras to be fitted into mobile phones. A natural source of omega-3 fatty acid starts to make its way into over 90% of infant formulas around the world. It was discovered in the 1980s when NASA was funding research for developing Mars life support systems, studying microalgae to see if it could be used as a source of food and oxygen. Galileo arrives at Jupiter after a 6-year journey and becomes the first spacecraft to orbit the planet. It launches the first ever probe into Jupiter, measuring the atmosphere. NASA's Pathfinder mission lands on Mars, carrying the first ever Mars rover, the Sojourner, with a mission to analyze the Martian atmosphere, climate, and geology. Ion thrusters are used for the first time on the Deep Space One probe. Thrust is generated by accelerating ions using electricity, creating a non-chemical space propulsion system.
The International Space Station begins construction in orbit. Russia launches a rocket carrying the Zarya as the first module of the ISS. The module provides storage, electrical power, propulsion, and guidance systems. 2 weeks later, NASA's Space Shuttle Endeavour takes the first American module called Unity to the ISS and attaches it to Russia's Zarya. Unity acts as a node, a connection point having 6 ports that will soon attach to other modules. Space Shuttle Discovery becomes the first shuttle to dock with the ISS. Onboard cargo includes the Space Hab module, parts for a Russian cargo crane and a US crane.
NASA's improved GPS technology that takes accuracy from 15 meters, 49 feet, down to 2 centimeters starts being used for everyday Earth navigation, pet tracking, and self-driving equipment. The first crew, 1 NASA and 2 Russian astronauts, arrives at the International Space Station to become the first people to live on board. 2 robotic geologist rovers, Spirit and Opportunity, land at different locations on Mars. NASA publishes a study of a possible Alcubierre warp drive. Equations show that it would be possible to create a warp bubble around a spacecraft, reducing travel times across the solar system from years to hours. Voyager 1 crosses the heliopause and enters interstellar space. SpaceX launches their Dragon spacecraft to deliver cargo to the ISS. Hired by NASA, it becomes the first privately developed spacecraft to dock with the International Space Station. Curiosity rover lands on Mars. During its time on Mars, Curiosity discovers evidence that there was water on the planet in the past. Mars also exhibits a seasonal variation of methane in the atmosphere, which can be a sign of underground life. Curiosity also reports that the radiation levels on Mars are dangerous for astronauts. The Rosetta space probe, built by the European Space Agency, houses a number of NASA's scientific instruments. It becomes the first spacecraft to orbit and fly alongside a comet. The European Space Agency's Philae lander that is on board the Rosetta launches and becomes the first to land on a comet. The Artemis program is announced, with the goal of landing astronauts back on the moon and building a lunar base and economy. Voyager 1 is still communicating with Earth and is 22.8 billion kilometers, 14.1 billion miles away. It is the most distant man-made object from Earth. SpaceX launches 2 NASA astronauts, sending them to the ISS, where they stay for 62 days. The Mars 2020 mission lands on Mars, carrying on board the Perseverance rover and the first aircraft on another planet, the Ingenuity helicopter drone. New experiments include one that produces oxygen from the carbon dioxide in Mars's atmosphere, allowing humans to breathe in their habitats and produce propellant. Perseverance lands in the Jezero crater, which may contain signs of ancient microbial life. The rover drills into the ground to analyze samples. The Ingenuity helicopter drone flies for 90 seconds per day. The drone finds the best driving route for the Perseverance rover and examines potential landing sites for future crewed missions. NASA's commissioned Peregrine 1 lander lands on the Moon. It begins to measure how much water, carbon dioxide, and methane is below the surface of the Moon, gathering data for future lunar mining operations.
The James Webb Space Telescope launches. With a mirror 3 times larger than the Hubble telescope, it sees further into our past, closer to the beginning of time, and determines what molecules and signs of life are in the atmospheres of exoplanets. 1 month after launching, the James Webb Telescope reaches its target orbit, 1.5 million kilometers, 1 million miles away from Earth.
Let's go for post sequence 4. Copy that.
The Artemis program launches a mission to the Moon, sending scientific instruments and equipment in preparation for the arrival of astronauts. Earth receives the first images from the distant James Webb Telescope. SpaceX's Lunar Starship launches. It performs the first working Starship-to-Starship orbit refueling, allowing it to deliver a payload of 100 metric tons to the Moon for NASA's Artemis program. NASA launches rockets to begin construction of the LunaNet, small satellites deployed to form a lunar constellation, creating the Internet of the Moon. Robotic landers, rovers, and astronauts on the Moon communicate with each other and to ground stations on Earth using the new system. LunaNet provides communications during deliveries of equipment to the far side and to the polar regions of the Moon. Space weather instruments send astronauts real-time alerts of incoming solar flares, giving them time to seek cover. NASA launches a crewed mission to return humans back onto the Moon. The astronauts live on the Space Shuttle lander while exploring the Moon's surface, preparing the way for future habitat construction. NASA launches 2 modules that begin the construction of the Lunar Gateway, a space station that orbits around the Moon. It acts as a transit hub for astronauts arriving from Earth before preparing for their trip to the Moon's surface and later to Mars. The Lunar Gateway grows as additional modules arrive, including modules from the Canadian, European, and Japanese space agencies. The Parker Solar Probe, launched in 2018, now enters the Sun's atmosphere and is the first spacecraft to encounter the Sun. SpaceX launches their first Starship to Mars, delivering life support equipment for the arrival of astronauts in 2 years' time, when the alignment of Mars and Earth are optimal again. On the Moon, exploration begins to find water. A test mission to redirect the path of a small asteroid belt object successfully alters the path of an asteroid. Small microthrusters land on the asteroid and move it off its course by a few centimeters. The Moon Base and Gateway Space Station are fully crewed. Teams of scientists and engineers occupy the first deep space human facility all year round.
2026, the year humans take off to Mars. The joint enterprise between NASA and SpaceX makes its way to the Red Planet. After a 7-month journey, humans arrive in Mars's orbit and deliver a second Mars copter probe to the surface. The crew orbit Mars several times, gathering data before making a landing on the surface. On Mars, the astronauts live in the spacecraft lander and begin using the equipment delivered 2 years earlier to conduct experiments. They also start creating locally produced propellants that allows them to return to Earth.
Back on Earth, NASA runs a 7-month immersive virtual reality therapy trial as a way to boost astronaut well-being on long flights. Probes on Mars discover icy water beneath the surface. A robotic probe lands on an asteroid and gathers data for potential mining operations. NASA's Rasor robot begins drilling on the Moon to excavate icy water deposits in the soil. The water is split into hydrogen and oxygen to create life support and rocket propellant. Astronauts begin testing the Moon's regolith, the loose soil, to develop a material for 3D printing lunar habitats. The Axiom space station, helped funded by NASA, goes online and begins replacing the International Space Station. Astronauts begin growing plants at the Artemis moon base. The second crewed mission arrives on Mars. Astronauts work in shifts. Off-duty astronauts stay within the virtual reality immersion pods. Low-level electrical pulses trigger their main muscle groups to prevent them becoming weak. The Habitable Mobility Platform, a large rover that can transport and house astronauts, makes its first trip around the Moon. It travels for 40 days mapping and exploring the lunar surface. Robot factories land on Mars and begin converting icy water and CO2 into water and hydrogen and methane fuel.
The Artemis Moon Base Camp is now made up of 3 main modules: the Foundation Surface Habitat, which houses 4 astronauts, the Habitable Mobility Platform, and the Lunar Terrain Vehicle, which is an unpressurized rover that transports suited astronauts around the lunar base. There are also power systems in place, along with resource mining and production systems. The Artemis Moon Base marks the beginning of the first human space colony.
The Moon Base begins expansion using solid modules and lightweight inflatable habitats. NASA launches an SLS rocket headed to Mars. It becomes the first to dock at the Lunar Gateway Space Station before transiting to the Red Planet. Testing begins on a NASA rocket that is powered by a nuclear reactor. Valkyrie R9 robots are sent to begin working at the Lunar Gateway and at the Moon Base. They take on dangerous tasks such as spacewalks, repairing air leaks and habitats, and gathering materials in dangerous terrains on the Moon. A spacecraft with a mega solar sail of 1,672 square meters, 18,000 square feet, sets sail for the distant stars. It uses beamed propulsion from ground-based lasers on Earth, the Moon, and Mars. A new Gateway space station begins construction in Mars's orbit, acting as a transit station for astronauts before preparing to land on the surface. NASA spacesuits are now made with self-healing and self-cleaning materials, which are embedded with soft robotics. The first crewed mission lands on an asteroid. They deploy a series of ion thrusters that maneuvers the asteroid towards the Moon, where it is converted into water and fuel. The NASA-funded Clean Skies project is in full force. Probes move through Earth's orbit, gathering and clearing tons of debris using foam. Asteroid-based mining begins. Robot factories land on ice asteroids, converting ice into water and fuel. Future deep space missions use these asteroids as refueling outpost stations. Testing begins on bioengineering humans for space travel. A group of astronauts undergo a gene editing procedure designed to reduce muscle and bone loss during extended space missions. Astronauts are now better suited to endure the multi-year journeys to the outer system. A robotic probe en route to Jupiter visits an asteroid fueling station. The test docking and refueling mission is a success.
Inter Astra, the first crewed mission to the outer system, launches. Humans venture to the outer solar system on a 13-year mission. The outer system spacecraft reaches Mars. The ship is replenished with life support and fuel at the gateway, and a slingshot maneuver around Mars sends the ship to the outer solar system. Inter Astra arrives at Jupiter, orbital insertion on Christmas Day. The outer system ship makes a precision landing on Jupiter's moon, Europa. Crew mine icy water to replenish fuel and life support for the return journey. The crew spends 2 weeks on Europa mapping and sampling for evidence of life, before setting off on their return journey.
Habitats constructed on the surface of asteroid Psyche create the first asteroid mining colony. The outer system ship, Inter Astra, returns to the inner system. The rigors of space travel have weakened the astronauts. The crew transfer to the Mars base, where they experience gravity for the first time since leaving Earth and begin their physiotherapy. Relativity Space begins testing 3D printing on the Moon, building the first spacecraft off-world. The first gene-enhanced astronaut group is sent on their first missions to the Moon and Mars. A small-scale Dyson structure begins testing. It focuses the sun's solar energy onto the solar sail of a spacecraft that begins traveling across the solar system.
NASA is absorbed into the newly created multi-planet organization, the United Planetary Space Agency. Fleets of robotic cargo vessels transport materials across the solar system to human outposts. The first Alcubierre warp drive goes online and begins testing, allowing humankind to explore distant stars. Embryonic gene editing of future astronauts begins, despite huge international opposition. The gene editing creates babies built for the rigors of long-term spaceflight. The first enhanced group of astronauts is raised to be planetary explorers.